Welcome back, everyone, and now it's time to talk about the difference between static and instance members. We all know from your first day of class and your first foray into programming, static void main, that is the entry point into your application. But what exactly does static mean? A couple weeks ago, I drew on the board how memory structures look like. And you can think of a class as a block of memory. One block of memory goes to the class definition. That block of memory also holds static members. Each class instance is a different block of memory. But the one thing they share is access to the definition, and thus access to the static members. So if you have multiple instances of a dog class, for instance, the private fields on each of those dog classes are specific to that instance of a class. So here we have dog Buster, and let's create dog Ernie equals new dog. And he is 14 inches tall, 80 pounds, and his name is Ernie. And for each of these dogs, we set a different height, a different weight, and a different name. And down here, if we go to the class definitions, int height, int weight, string breed, string name, these are all local to the instance of a class. So if I change Buster's height, it won't change Ernie's height. If I change Ernie's weight, it won't change Ernie's weight. However, something that is declared static can be shared through all the class instances because it's common to the definition of the class, that first block of memory shared by all the other class instances. This is true for any class member. It could be a field, it could be a method. These are all common and shared. The other feature of a static member of a class is that it can be called by your code without having to declare an instance of a class. So let's create a new method without having an instance of a dog. We can take the bark method and make it static. You make something static by saying static. You put the static keyword in front of a method definition. Now if we go back up here, and let's say we want to have the dog class bark, you simply call the type dot the method name. You can access a property or a field that's static through dot, but it all is on the class name, not the instance name. So before, when we talked about bark, we called buster.bark. But as soon as we make it static, it's no longer accessible at the instance level. It is now at the class definition level, dog.bark. Maybe we want to, well, let's run this real quick. Woof, we called that static method. Maybe we want to keep track, for instance, of how many times every dog barks in total, whether that be Buster, Ernie, or any other instance of dog. We can create a static field, static number of barks, and it'll be an integer, static int number of barks, and we will set this initially equal to 0. Unlike normal fields, static fields, you should initialize. Here we want to initialize it to 0. And then let's create a static property. You can do that to properties too. Public static int number of barks. Alright, and we'll go over this after I type. There's just a lot of things to type. And then every time we call bark here, let's increase the count by 1. And then how about every time we create a new dog, we have that dog bark? So here in the public dog constructor, we'll call dog.bark. Now this looks very confusing, so I will talk about this in a second. We're going to remove this call to dog.bark. So what have we done here? We have a class, and we have instance members, and we have static members. And they're a little intertwined, so let's break this up a little bit. So you'll notice, for the sake of clarity, I specified fields and methods and properties in separate areas in our class definition. Let's break this up further. Let's do static members and instance members. You may want to do this in your code because it offers a lot of clarity when you break up what's static and what's instance and when you want to use what. So in here we have static fields, we'll go over this in a moment. Sometimes I feel like Bob Ross when he goes silent while he's painting his happy trees. We'll take a little of the blue off the palette here and paint some sky. Alright, so I have cleaned this up, hopefully to help our brains flow a little bit. So again, break this up into your mind into two parts. There's the thing that's shared, and that's static. That is represented here by the static members. We have a static field, the number of barks total for all instances. We have a static property that is the getter or setter for the static field number of barks. This will be used to get or set the number of barks. And then we have the static method called bark. And when we call bark, we write a line to the console, woof, and then we increase the static field number of barks by 1. So that's what we've done. That is what's shared between the classes. Now, the instance members are the parts of the class that are unique to each instance of the class we've created. So each dog is unique. Buster and Ernie here are unique. And what we've done here in the instance is every time a dog is created, no matter which instance, the dog will bark upon creation. Woof. When it barks, it will call the static bark method. It will write woof to the screen, and it will increase the number of barks by 1. Then what we will do here is we will write to the screen the number of barks. And we access it through the class level dog, not the instance, Buster or Ernie, number of barks. some string interpolation to clean it up. All right, so we've created two dogs, Buster, Ernie. In the constructor, it calls the static method bark. That increases the number of barks, a static field, by 1. And then, down here, console.writeLine, what we should see is number of barks for all dogs, 2. Because again, this is defined as static at the class level. So even though we're calling it on the instance methods, it's common, it is shared. So here, it will increase this 1 and 1 to make 2. So we'll see 2 woofs on the screen and 2 barks. Here we go, woof, woof. So when we created Buster, he goes woof. We created Ernie, he goes woof. Number of barks for all dogs, 2. Because again, we've used static members here. It's shared between all the class definitions. Even though these instances have their own values, this part is shared. Now again, just to prove it, we will write the information for Buster.display information to the screen. Write some blank lines here. And Ernie.display information. And once again, these methods are instance methods. So when we run these, we see they maintain all their individual information in their block of memory. But again, the static information is is common to the class itself, the definition, and that shared block of memory. So if you're ever looking for a way to communicate between classes, for instance, classes that may not know that each other exist, you could use static as a way to broadcast messages, for instance. If you want to let all dogs know that food is available, but you don't necessarily know how many instances or what instances of dog you have, you could use static methods in order to share that common memory and share a message. Just again, the order of definition, and again, with regards to visibility, that matters whether it's static or not. Static or instance, you have to specify the protection level. The order of the definition here, and here with number of barks, public static int, protection level, static or instance, where instance is nothing, type name. This also applies to methods, but again here, static public void bark. You can flip it around if you want, the visibility and the static, but traditionally, and I did this wrong, it should be public static void bark. As an example here, it will yell at you if you put the type out of place. Don't want to do that, but public and static, you can interchange them here, and it will not yell at you, and it will still compile properly. But traditionally, it's visibility level before static or instance.